Good morning, good afternoon. Thanks for tuning in. This lecture is on Energy Star for New Homes program. Just a brief introduction. The Energy Star for New Homes program is basically a program that is above code minimum, so above SB 12, and it aims to be about 20% better across the board than SB 12. We're going to learn about the program, how to implement it, some of the compliance strategies. It differs a little bit from SB 12, but the SB 12 is a good base for moving forward into Energy Star. This is going to transition later into some other standards, such as Passive House and Net Zero, which are a little bit more niche standards. But Energy Star for New Homes is a program that people use to builders use it to advertise their business as a trustworthy and energy efficient business. It adds value to homes. It's a third-party standard, so it's not a government body like the building code. It's a third-party standard that also requires third-party verification and testing. And there are some other programs that go along with it, such as grants. There's some tax savings for businesses when you have Energy Star buildings, but the main gist is that it's a third-party verification that's saying that your building is built to a specific standard that's set out to be about 20% better than code minimum in regards to building science and energy efficiency. Energy Star is a bigger brand that also governs certain testing credentials for appliances, furnaces, electrical devices. But this standard that we're looking at for our program is the Energy Star for New Home standard. So we're going to learn how it relates to Ontario, and then how we can utilize it to find compliance paths and how to understand what the Energy Star program's goals are. I'm going to play a brief video here to help, just a brief introduction on what Energy Star is from their YouTube page.
I'd like to introduce you to the United States Environmental Protection Agency's Energy Star Certified New Homes program. In the next few minutes, you'll learn about the value of Energy Star certified homes and how partnering with Energy Star gives builders a market advantage. Let's start with the Energy Star brand, which has become one of the most powerful consumer brands in the United States. The government-backed Energy Star label is recognized by 87% of consumers. And 90% say that it influences their purchasing decisions. Energy efficiency is now playing a critical role in the decision-making process for new homes as well. In fact, 81% of consumers say they choose one new home over another based on its energy efficiency.
Going from a two-bedroom apartment to a house that's over 4,000 square feet, I expected them to, to be a dramatic increase in the cost, but not the case. And what we used to pay in a smaller home, we're now paying less than that in a bigger home.
I mean, who doesn't want to save money?
Over the past 2 decades, more than 1.6 million Energy Star certified new homes of all types have been built nationwide, from production to custom, for first-time homeowners to luxury home buyers. Building a home from the ground up to be highly efficient also improves other factors that homeowners care about, like comfort, quality, and durability. Some lenders offer special mortgages for Energy Star certified homes.
I used to live in this apartment where I had to shove scarves along the door frame and at the bottom when I got home because I could actually feel the draft.
Plus, partnering with Energy Star distinguishes builders as leaders in energy efficient construction and environmental stewardship. And peer and public recognition can translate to a real market advantage. So what specifically makes Energy Star certified homes have more value than standard new homes? An Energy Star certified new home delivers energy savings up to 30% compared to typical new homes. And they're verified by an independent third-party energy rater to ensure they meet or exceed Energy Star certification criteria. This gives buyers the added confidence in their new home's energy performance and ensures that the construction details that impact efficiency, comfort, quality, and durability are built into each home.
The builder actually showed us, he gave us a sample of normal insulation and insulation that they used, and we could see how much thicker that insulation was.
For each home that earns an Energy Star label, there are specific quality inspection checklists based on the best building practices that must be completed. These checklists cover the complete thermal enclosure of the home, including comprehensive air sealing, quality installed insulation, and high-performance windows and doors, as well as the design, installation, and commissioning of high-efficiency heating, ventilating, and cooling systems. Additionally, each Energy Star certified home must also have all of the program required water management construction details built in. These systems protect roofs, walls, and foundations from rain and moisture. A combination of tried and true best practices and an integrated approach to design and construction adds up to homes with better durability, better comfort, and reduced utility and maintenance cost. And by employing energy efficiency construction practices, partners report increased customer satisfaction and fewer complaints and callbacks. To learn more about the Energy Star certified home program requirements and verification process, please watch the Energy Star Builder Orientation video or visit energystar.gov/laws.
So, good little introduction there. A few things I wanted to point out from that video. There was the windows that had the Energy Star sticker on them. Those mean that they meet Energy Star's ratings for windows. That's a whole separate part of Energy Star. Another thing, they talked about water management. They also talked about how that prolongs building materials. So some of the goals of Energy Star aren't just directly related to utility costs or air tightness, but also the preservation of materials long term in a building system. And that's kind of what Energy Star focuses on, is an all-encompassing packages to make sure your building is having a lower environmental footprint and lower operation costs long term. So that video was American. Energy Star is an international program. That video was out of the States, and they had said it was aiming to be 30% better than code. In Canada, we'll see that it's actually aiming to be about 20% better than code. That's the program's requirements are the same, but it's just that Canada's building code is a little bit stronger, mainly due to our cold climate, in regards to efficiency. So same standard, maybe about 30% better than American code, but only about 20% better than Canadian code. Those percentages are averages across the board. They're not related to, oh, if you need R value in a wall for SB12 and it's 10, it doesn't mean that it's just 20% better at 12 in Energy Star. It's an all-encompassing 20% goal that they're trying to meet there. So we'll go through this here and we'll go back and forth between here. I'll show you before we get going through the slides that this is my thing's in the way. This is in your course content section on Brightspace, and this is the Energy Star for new home standard for Canada. Like I said, the standards are the same, but this is the Canadian copy version. And the reason they make them specific to your location is that we'll see that there's different standards for different zones in Canada. Just based off, they're aiming at the same goal, but it's based off of climate zones and everything like that too. So as we move through it, we'll see that. Oh, here's the 20% here. So making the energy target more stringent, an Energy Star qualified home is approximately 20% more efficient than a reference house. This level strikes a balance between the premium level of energy efficiency associated with the Energy Star label and an acceptable incremental cost relative to a house built to minimum building code requirements. So that's another big thing about Energy Star is that they're a thing that Energy Star strives for is not make it terribly more expensive to reach their goal. If part of their goal is cost savings long term, if the math doesn't add up and it costs too much up front to get long-term energy savings, then it doesn't make financial sense to do that. And that's kind of a balance that energy efficient and environmentally friendly practices across all industries have been struggling with and have balanced for years. So it's kind of that goal of, does it make sense? Solar panels, for example, are a very tricky one in Canada because our UV isn't terribly strong here, and it's only really for a small portion of the year that we get good, consistent UV in a lot of parts of Canada. So solar panels are one of those things that kind of just fall on the line of, is the upfront cost worth what you're going to gain? And you have to think about how much energy you're going to receive back from the solar panels, but then also the lifespan of the material. So the Energy Star kind of takes in all those different factors and tries to make it a cost efficient 20% better than a code minimum house. And remember that SB 12 is the code minimum for energy efficiency. It's a supplementary standard to the code, but it is the code minimum when it comes to energy efficiency. So this part of the document kind of just outlines the different key changes in Energy Star and what it's striving for in this version 12.7. Version 12, but this is 12.7 that we're going off of. This was put into practice on April 1st, 2016. And so as we go through this, we have our table of contents. It's actually very similar to SB 12 in the layout of the document. So we have our definitions, just like SB 12, minimum requirements. So this is kind of all the technical jargon as we go through here. And then compliance options. So this is very similar to our compliance packages for SB 12, but there's a different way they calculate them in Energy Star. And I'll show you that just so we have an idea of what we're looking at. Here is all the different provinces and territories. And then Ontario, we're on page 54. So let's go down to 54 and have a look. I'm going to try to make this bigger, actually. So Ontario, just like SB 12, 2 climate zones, less than 5,000 degree heating degree days, zone 1, more than 5,000, zone 2. Remember that Southern Ontario and most of South Central Ontario, but including the Niagara region, is in zone 1. Zone 2 is mostly related to Northern Ontario and some of the colder climates in Ontario. Here is what we're looking to save in an Energy Star certified air conditioner, performance targets. This Hot 2000 version, this here is a Hot 2000 is a modeling software for energy efficiency. We'll have a quick look at what Hot 2000 does in a bit. It's basically a modeling software where you can put in all the different aspects of your home before building it. So during the design phase, and it will calculate your energy efficiency on a whole. And then you can also analyze certain features. And that takes into account thermal bridging, air conditioner efficiency, heating efficiency, roof insulation, exterior finishes, and it basically models where you're at before you start building. So this kind of goes in hand with planning for green from the start and how valuable that is. Hot 2000 is developed by Natural Resource Canada, so it's actually a government sponsored program, and it's something that's used by energy advisors, the people who would audit your homes for energy to make sure you're meeting SB 12 or Energy Star. And that program does cost. We won't get into the program. It's something that's a whole separate course to learn how to use it, but it's important to understand what it does and how it relates. There's other modeling softwares, but this is the predominant one in Canada that's used, Hot 2000. So these in SB 12 or in Energy Star, I'm sorry, are builder option packages. So it's very similar to SB 12 in the sense you pick certain things in each area of the home, and then it all comes together to make an acceptable solution. The thing about Energy Star that's a little bit different is you basically pick a package for, so these are the minimums for zone 1, and it's one set of standards, but you get points for everything you go above. So as you go to the next page, as we go to the next page, these are options. So these are packages, and then these are package options after. So as you'll see this point system on the right side of the page here, it shows point 1, point 1, point 2, all these different numbers here as you go down, and you can get to a certain number that's the minimum to get to meet your builder option package to meet Energy Star. So to not be too confusing, you basically start with a base package with Energy Star. These are all the minimums that you have to have in your climate zone. And then you have to reach, say you had to reach the number 2, you'd have to start adding up some of your things that you go above the minimum, and you get points for them. So if you go, and then it continues on to domestic water heating, combined space and water heating, combined space and water heating, attached houses and MURBs. Remember, MURB stands for multi-unit residential buildings. So that's talking about apartment buildings when it comes to MURBs. And then if you see here, like some things are different for these multi-unit buildings. So this is drain water heat recovery, DWHR. This is for single family homes, DWHR for MURBs, multi-unit residential buildings. So they're a little bit different for what they get for when they recover drain water heat. And then it's the same thing for the other climate zones, or for the other provinces. They have similar charts. This is Prince Edward Island, for example. They only have one zone. And it looks like in Prince Edward Island, they always have less than 5,000 heating degree days across the province. So they have one set of standards, but they also have options that they have to meet to get to the minimum number. So stay with Ontario. So Ontario's page 54 here. If we go up to compliance. What we'll do is actually, we'll come back to this. Let's go through the slides. We'll come back to this. We'll get a better understanding, but I just wanted to kind of give you an introduction. Because you're already familiar with SB 12 and what these environmental codes, how they're laid out and what they do. I just wanted to give you a brief overview of kind of what we're looking at with Energy Star. It's not a completely foreign object that we're looking at. We're familiar with a lot of these measurements, units, values, what they're trying to do. There's our famous word fenestration again. That's Windows. So we're carrying on and looking at a higher standard, and we're going to do that a few times through the course here. Is we're going to look at the next higher standard, the next higher standard. These ones are very similar. This one's very similar to SB 12, but Passive House and Net Zero are really a step above into being almost zero cost energy efficiency levels. So what we're going to do here is go to our Energy Star slides. And we'll start going through them. Just going to take a 1-minute break here. All right, we're in the slideshow, back in the slideshow here. So we're just going to go through some of the core concepts of Energy Star for new homes, and we'll flip back and forth between this and the document to get a full 360 understanding of the workings of Energy Star for new homes program. So this is a foundation built on our SB12 module. We're going to kind of carry on from that, what we learned in that, and how to look at things that are above the code minimum. Practical focus for our course is learning how to apply Energy Star New Homes design, coordination, layout, and then field execution. That's where we come in as carpenters. If people in this course go on to get into design and things like that, then we'll have a good background understanding in the field. But as far as this course is concerned, for carpenters doing the work on site, we're all about how to execute in the field. Field execution in carpentry, as we've talked about throughout the program, it does have a strong relationship with how well you understand the topics. And then critical outcomes, we want to be able to select compliance paths. We want to be able to coordinate minimum requirements and prepare for verification inspections. So in SB12, it's government body, building inspectors coming to inspect and make sure you're meeting the minimum. With Energy Star for new homes, it's third-party compliance inspections. So you actually have to bring in a third-party energy advisor that comes in and does the testing to make sure you're meeting it. Energy Star for new homes isn't something you just complete on your own. It's through certified builders. This is very similar to the context, but it's just a quick layout of what learning objectives we want from it. So explain the fundamentals, compare compliance paths, apply regional specs, so things that relate to our region that we're working in, and then master the compliance approaches and how we bring them to the real world and on site. So what is Energy Star for New Homes? It's a Canadian program recognized by Natural Resources Canada that delivers new homes approximately 20% more efficient than a typical code built reference. I put Canadian program because that's the one that we're dealing with. Energy Star for New Homes is an international standard. Our version 12 Canadian version is a Canadian program, and it's through Natural Resources Canada. Why choose it? It delivers lower utility bills, improved comfort, verified performance, better durability, and high market resale value. When does it apply? It's for eligible low-rise housing types during design and construction, and it requires enrollment and third-party verification. When it comes to low-rise housing types, that still does include multi-unit residential buildings, those MURBs that we talked about, just up to a certain size though. So program benefits, energy savings, 20% more. So not only does it want a 20% better house, it's also this kilowatt electrical savings per year that's outlined in Energy Star is about 20%. Tighter envelopes, reduced drafts, mandatory balance ventilation. So back to that HRV and ERV. Higher durability, like we said, one of the ways they approach being a green and more cost-efficient building method is by having materials and building practices that last longer. Marketability, so better resale value because of the label, and really that third-party stamp is what comes into giving it that true trustworthy label. And then predictability. You know what you're getting when you get an Energy Star home. You know what it meets. You know what rigorous standards it's been built to. So it's a reliable and predictable target to reach. So Energy Star for new homes versus SB12, about 20% better. We've heard that a few times now. SB 12 is the code baseline. So when we looked at those builder option packages versus compliant paths, so in Energy Star for new home, there's a builder option package plus options. So core is related to the package, and then options or performance modeling, HOT 2000 type of modeling. So you either have the option to go through building to the minimums of Energy Star with your options and saying how you're going to reach it and then getting it verified on site, or you do performance modeling through a energy advisor or energy efficient focused architect, and they can design performance modeling. You don't also need to be a certified architect to do some of this work. As a carpenter, you can go take HOT 2000 courses and get certified in how to design performance models. SB 12 accepts Energy Star as a compliance path. So it's above, it's recognized. So if you go above and get Energy Star, you automatically get SB 12. So it's not just some kind of freelance body, it's directly related to the Canadian government and the standards here in Ontario. Mandatory air tightness, electrical savings of more than 400 kilowatt, HRV requirements. And then this one is all municipal inspection focused. Building officials verify the code minimums. This is the big difference in how you get it specified is there's third-party energy advisor under licensed service organization that would do your permit application or your Energy Star approval for building the SB 12. You have the permit approvals through the city inspectors. So compliance paths overview. How do you stay in compliance with Energy Star for new homes? You can either do the prescriptive approach like we just talked about, so the option packages plus options list, and you can also do energy modeling. So that's called the performance approach. So you model the home using that Enercan approved software, HOT 2000. The proposed design must meet or exceed the Energy Star new home's target relative to the house, relative to a reference house. This is where your design flexibility comes in. It's like code where if you want to build just strictly within code, you are bound to what you can build. The code gives a wide range of standards, but you are technically bound into how you can build. If you want to build outside of code, you have to get engineer drawings for it. Well, it's the same with building for Energy Star for new homes. You can either build within their requirements and meet it, or you use the performance approach, which means you have unlimited flexibility, but you have to prove that you're still meeting the targets. And then regardless, there's mandatory minimums you have to reach. So either way, you're reaching the minimums of the program, and it's going to be verified on site by an energy advisor. So minimum requirements, you have to meet the local building codes and regulations. You can't not meet building codes just to be in compliance with Energy Star for new homes. You have to meet both. When it comes to the energy side, if you're meeting Energy Star for new homes, you are surpassing SB 12, but it doesn't mean you can slack on other parts of the building code with framing and structure and layout. Air tightness testing, there's specific targets outlined by this document CAN/CGSB 149-.10. This is probably a pre-engineered document that shows the minimum air tightness that you have to have for your home. We'll just be dealing with what the outcomes of that document are, which will give us an ACH 50 unit. So it'll give us a maximum air changes per hour at 50 pascals. Insulation and fenestration. So insulation in windows and doors, mandated minimum effective thermal resistance for key assemblies, and whole assembly performance for windows and doors per regional specs. That's something to talk about with windows. Windows aren't just, you can't have a full wall of windows and say they all meet U 1.5 or whatever U value spec. It also takes into how many windows you have on a certain wall or around the whole structure. Windows are generally a weak point in a building envelope as far as thermal resistance goes. So it's important to understand that you can't just have unlimited windows on a home because they meet the minimum value. It's all about the percentage of the home's wall square footage that's covered in windows and doors. And then ventilation systems, they're all required proper ducting, balancing, commissioning verification. So that commissioning verification, that's probably done through usually the installer. Most people that install ventilation, heating, air conditioning in homes, they're certified to put their stamp on it and say that it's meeting the standards. The energy advisor, when they come in, they'll just verify that with the on-site. So building code, building envelope requirements, air tightness when tested at 50 pascals. So that goes back to the ACH 50. Remember, it's pascals. Pascals is a pressure rating. We know that from SP 12. Opaque assemblies. So this is a weird way they put it in Energy Star for new homes. But what opaque assemblies means, the word opaque just means it's not transparent or translucent. You can't see through it. It's just their way of saying walls, basically. But it's their way of saying walls, but not including windows and doors. So that's just what the opaque assemblies means. Just remember that if it comes up in a quiz, that is what they're referring to. Fenestration indoors, use Energy Star certified or compliant U value products per Ontario specs. Proper flashing, shimming, and sealing are mandatory. Continuity and transitions. So align your water, air, vapor, and thermal layers across transitions, rim joists, top plates, balconies, all those places we've talked about that are difficult to do on site and that often get messed up when people are building in different phases. These are mandatory to be continuous in Energy Star for new homes. The energy auditor will, or energy advisor that comes to do your verification on site will be checking all your details to make sure they're up to standard. Mechanical systems. The requirements for heating, cooling, ventilation, and drain hot water. So space conditioning must use high efficiency furnaces or heat pumps meeting specified performance levels per the selected compliance path. So per what we're looking at, where the region, the zone, and our option package. Ventilation systems, HRV or ERV is mandatory. Remember that we always need, or sorry, shouldn't say always, but the general rule is that if your ACH 50 is below 3, you're going to need some sort of mechanical ventilation system in your home or building. You're not going to find a home package in Energy Star for new homes that has an ACH 50 above 3. So HRV or ERV is mandatory in all Energy Star for new homes buildings. And then domestic hot water, we're not going to focus on this too much. We just need to know the how to use it in a compliance package. So domestic hot water recovery is part of the program, and it will be outlined in the builder packages. Electrical savings, the target, like we said, 400 kilowatts per kilowatt hours is what we're trying to save per year versus standard products. When they say standard products, it's basically just the average that's happening across the market. We're trying to go above that by 400 kilowatt hours. Lighting, LEDs, so specifying Energy Star certified fixtures and bulbs is the most common way to earn the credits. Appliances, Energy Star certified models. Motors, they have to meet a certain energy efficiency rating. Strategy, so create a savings mix during design phase. Don't leave this until the end. So you start to look at all your different pieces before the design phase. We don't want to be trying to figure out how to get to the Energy Star standard later in a project. When you're doing Energy Star, you want to have all your models picked out beforehand and making sure that it all adds up to meet the requirements of the program. So in a prescriptive approach, what we do is we select our builder option package, what we looked at in the Energy Star earlier. We select our package, and for Ontario, it's already selected for you based on whether you're in zone 1 or zone 2. You lock in your core specs. So everything, your core is your builder package, and you commit to the mandatory envelope RSI. So RSI are all of our value, thermal resistance, your fenestration U values, the quality of your windows and doors, your HRV efficiency, and your drain hot water efficiency from the column that you're working out of. Then you add options. So you select the required number of additional options from the approved list to meet the package total. And then for the electrical efficiency side, you document where your savings are and you get to your 400 kilowatt hour minimum improvement requirement. So critical coordination rule. I wanted to put this in here. You cannot mix specs across different BOP columns. Substitutions must follow strict rules or switch to performance path. Remember, the performance path is when you get it modeled by someone who uses HOT 2000 or another software that's approved to model everything. If you are going with the prescriptive approach, which is following what's outlined for us in Energy Star for New Homes document, then we need to follow the building option package that we are choosing. In Ontario, like I said, depending on where you're building, it's already chosen for you. We are in zone 1. There's one builder option package for zone 1. And then we go to the options section to figure out how to meet our package total. When we go to, where's our Energy Star for New Homes? We go here, full screen. So we go into it. Summary of changes. Don't gotta worry about this. This is just what's been updated for the new one. So scope and application, minimum requirements. And then we go to, let's go to minimum requirements. We're going to find what the minimum points we need to pass the program. So actually this table here is our air tightness. Not related to any of the building option packages, but this is, as you can see, the maximum. Oh God. As you can see, the maximum ACH 50 is 3 in Energy Star for New Homes, for attached homes. So this is how our two compliance options, as we were just talking about, what we were just looking at was the prescriptive approach. So Energy Star homes built following the prescriptive approach shall comply with 5.2.2 to 5.2.4 in addition to meeting the minimum requirements laid out in section 4. The prescriptive approach allows a builder to choose a builder option package that has been predetermined to meet, on average, the energy performance specifications for an Energy Star qualified new home. No modeling is required under this approach. If we're staying the prescriptive approach, we don't need professional modeling through HOT 2000 or some other software. We are choosing the outlined options in this document, and we are good to go that way. So builder option package shall comply for the relevant region and climate zone. For us, Ontario Zone 1. The lowest level of the following installed in a building or unit of a building shall be applied for the purpose of compliance: thermal resistance, Energy Star climate zone for windows and doors, efficiency of mechanical equipment. For air tightness and MERBs, the following shall apply. For MERBs with level 2, 3, 4, or 5 per Appendix A. We can have a look at Appendix A after, but we're not going to focus on MERBs right now. BOPs are applied on a per building basis in cases where measures in MERBs such as attic insulation can only be applied in some units. These measures may be used for meeting compliance for the whole building. Measures that normally apply to each unit, such as windows or mechanical, are applied to all units. Refer to the builder option packages for special conditions. So that's for the prescriptive approach. For the performance approach, Energy Star qualified homes built following the performance approach shall comply with 5.1.2 right here, this section right here, to 5.1.4, in addition to meeting the minimum requirements laid out in section 4. So these ones are done using approved compliance software. There's that HOT 2000 version again. So the energy target in 5.1.2 shall be assessed using HOT 2000 unless otherwise specified in section 6. In section 6, there's a list of other softwares you can use or a link to that list. I can't remember if the list is in this document or if it's a link to it. So as we go down, I'm just trying to find the section right now. I can't see where, say for Alberta. It has our minimum points that we have to get for our builder options. I'm blanking on where to find our points right now. Just give me 1 second. Oh, yeah, it's right in our table. Sorry, it's right in our builder option packages. So if we look at the bottom, I'm just going to use Alberta as an example here because we should be able to use this anywhere across Canada. And it's good to look at different packages. So if we're in Alberta and we look at and we choose Energy Star for new homes for zone 1, this is our builder option package right here. And if you look at the bottom line, it says BOP options required. And then this is our minimum number of points we have to gain. On top of these option packages right here, we have to gain at least 2 points if we're going to go in zone 1. So then if we were to pick this option package, and then we go to this chart right here, which is our options afterwards, our additional options. If we're in package 1, remember we have to get 2 points. Or if we're in zone 1, we have to get 2 points. So we can start picking these certain areas to gain more points. It's no one's telling us how we have to get there. We just have to get there by adding these together. So if for air tightness, we went, or let's go to let's go to ceilings below an attic. So if we go for R52 at the heel, which is where the truss meets the wall or the rafter meets the wall, with R60 across the board, so across our ceiling system, we'd get 0.1 points. If we do R40 in a cathedral ceiling, we get 0.1 points. If we do walls above grade, so these are our exterior walls above the foundation wall, so our framed walls on the outside of our house. If we go to 19.4 as our R value, or we can do RSI. If we go 3.41 for RSI, we get 0.5 points. If we go to all the way up to 4.48 RSI, so better insulation in the walls, we're getting 1.4 points. So this can help get us to our builder option package points, or our builder option points a lot quicker if we really up the R value in our walls. If our foundation wall, say we just wanted to meet that 2.0, quick and easy, we could go to R25 or RSI 4.48 in our walls. We get 1.4 there. We could go on our foundation wall. We could do RSI of 4.19. So we'd be at 0.5. So then we'd be 1.4 plus 0.5. We'd be at 1.9. And we just need to find 0.1 points to get us up to 2. So we could go for our unheated floors below frost line. So let's go our basement slab. So our basement floor, if we have a foam board under there that has an RSI of 0.88, then that gives us a 0.1, and then we're at our minimum 2 points. So we had to meet the minimums of here, but then we upped our walls above grade, we upped our foundation walls, and we put insulation under our basement floor, and we got our 2.0, and then we're good. As long as we stay within all of these, that meets our standard. Let's do another one here. Let's go over to, let's go somewhere exotic. Let's go to Newfoundland and Labrador. So let's pick something in zone 3. So in the coldest parts of Newfoundland and Labrador, we'll go to zone 3. So go to our builder option packages. We'll go to zone 3. We'll have to pick all of these here. This whole section will have to meet. As you can see, this was in Alberta too. I should point this out. These things here say space heating. These requirements, I gotta stop clicking on the screen because it goes to the next page. These space heating requirements apply to all 3 zones. That's why it's not split up. Same with the domestic hot water. This all applies to all 3 zones. The ventilation, all 3 zones. Electrical savings, all 3 zones. There's that 400 kilowatt hours per year. Again, that's pretty standard across the board for Energy Star. For zone 3, we need to meet not only higher values in our base option package and our builder option package, we also need more option points to be able to be an Energy Star home in this region. So for zone 1, we'd only need 2.6. For zone 2, we need 2.8. In zone 3, we need to make up 2.9 builder option points. So we go to the next page, and here's everywhere we can get our points. As you can see, as you get into colder zones, they don't give out points quite as easily. So some of these R values that you would have gained points for in zone 1, you're not gaining points in zone 3 because the minimums are already higher than what you would have got points for in zone 1. So We can look at that real quick just to clarify that point. So in let's go at ceilings below an attic, 100%. So if you go R60 in zone 1, you get 0.1 points. Because ceilings below attics are only requiring R49.2 minimum. So if you go above that, you get 0.1 points. But in zone 2 and 3, they're already basically specifying 60 R value as the minimum for your attic. So if you go over to your point system, you're not going to get points for going above R60 or to meet R60 because you already have to be there. So we're going above and beyond the highest standard now in a zone 3 scenario. So as you can see, you're also getting not many points as you go down the board for a lot of these things. You're not getting these 1.9s laying around, so it can be a lot harder to meet the standard in a colder climate zone. So let's look at the example here. What I'll do is I'll actually pull up losing my page. I'm gonna pull up a I'll pull up a spreadsheet. Mhm. It's hard to see everything in this collapsed format. There we go. Merge. So builder options, Newfoundland and Labrador, zone 3. So let's start putting together some options that we can get to in zone 3 to meet the minimum requirements. So if we're trying to get to 0.9 or 2.9. So our goal, so we'll put options here and then we'll put points here. So let me spread this down a little bit. So let's pick the highest RSI walls. So let's go RSI 4.79 walls. So walls 4.79 RSI. That gets us RSI 4.79. That gets us 0.9 points in zone 3. Now if we go to here. Now, if we go to foundation walls, let's pick our highest there. So let's go RSI 4.19 foundation walls. Foundation walls. What was it? 4.19 RSI. And that gets us 0.4 points. So let's go like that. Let's go for our slab. Unheated floors below frost line. Let's go RSI 1.76. So just call it floors below frost. And we're gonna get those to 1.76 RSI. And that brings us up to, gives us another 0.4 points. So right now we're at 0.9 plus 0.4 plus 0.4. So 0.9 plus 0.4, 1.3 plus another 0.4, 1.7. So we still have to make up a full 1.2 points to get up to our total of 1.9 or 2.9, sorry. So let's go to our windows and doors, our fenestration. Let's do the zone 3 level doors or windows and doors. So if we go Energy Star zone 3, zone 3 fenestration, and we'll get another 0.4 points there. And then if we go to air tightness, you see you can get a lot of points in air tightness. Why did I do that? You see, you can get a lot of points in air tightness. This is our air tightness. If we up above our level 1, our base level air tightness, and we'll see what the ACHs are that relate to these levels. We can go look at that right now, actually, after we do this example. But right now we need to make up 1.2 after that. So we're at, should be 0.8 left to make up. We're 2.9. So let's go. So we're 0.9, and then we'll go to plus 0.4 is 1.3, plus 0.4, 1.7, plus 0.4, 2.1. And then if we just up our air tightness to level 2, or sorry, to level 3, as you can see, air tightness level 3, that brings us another full 1.0 points. So air tightness level 3. And then if we do the sum of all these, where's our functions? Sum of all these right here, 3.1. We're above our 2.9. We meet Energy Star. If we do all the requirements, as set out in this builder option package, Energy Star for new homes, zone 3, and then we meet 2.9 option points on top of that, which we did here by adding these options in. We get to 3.1. We meet the minimum for zone 3 in Newfoundland and Labrador. So let's go back. So what I'm going to find is our chart for all the different levels of air tightness. Let's go up to the table of contents. There's a chart that specifies, remember we upped our air tightness to level 3, and that got us some additional points there. Air tightness on page 11. Air tightness metrics right here. I don't know why that happened. Air tightness metrics. So here we go. Here's how you get to the different levels of the air tightness to get more option points in the builder package. So this is for attached buildings, townhouses, apartment buildings, MERBs, as we call them. Air tightness metrics for detached buildings, so single family homes in most cases. And then air tightness metrics for attached buildings, Manitoba only. They must be special, extra cold there. This section here, no, sorry, detached buildings, go off of detached. So here is our ACH, right? At 50 pascals. And then these are air change ratings for the different levels. So we're going to go off ACH pretty much exclusively in this course. It's the easiest way to understand air changes per hour or air tightness. These other ones are, I think this NLA stands for normalized leakage area. And then this is normalized leakage resistance or something along those lines, but it's measured in volume per square per how much surface area is coming out. So it's a measure of how much leakage area you have in your home. And it's just very confusing, and it's more for the performance metrics, so they can measure it on, because when you're doing things on a computer, you can't just fill your house with 50 pascals and figure out how much air changes you're having. So this is more for the performance approach for the modeling softwares. This is what we're going to go off. So if I ask on a quiz, what ACH 50 rating is required for a level 3 air tightness in Energy Star for new homes, this is where you're going to have to go. And so if you look for a level 3, like the one we just specified for Newfoundland and Labrador, then you're looking at a 1.5 ACH rating. And this is all off of ACH 50 as specified in the early section on page 11. ACH at 50 pascals. So to get your ACH ratings, you go to page 60, or 68, which is the last page of Energy Star for new homes. Appendix A, air tightness metrics. Remember that each table is for either attached buildings, detached buildings. Maybe I'll get tricky and throw a Manitoba scenario in there. If I ask what's the level 3 in Manitoba, 1.5 ACH. So let's go back to the slides. That was kind of the prescriptive approach, right? That's using the document and figuring out all your different points you have to hit to be in compliance with Energy Star for new homes using the prescriptive approach. really don't like how this program automatically sends you back to the first page. So, prescriptive approach. Select your option package, lock in your core specs, add options like we did for Newfoundland and Labrador and Alberta. You add your options to meet the minimum, and then you have to document your savings electrical wise. We won't be dealing with this part. This is for the designer and the electrical contractor to work out. Performance approach. Use the approved software. Must use Enercana approved simulation tools. HOT 2000 is the main one out there. Meet the energy target. The proposed design must meet or exceed the Energy Star for New Homes energy target. And then this, of course, allows design flexibility. If you have more unique designs that aren't fitting within Energy Star's predetermined scenarios, you need to go to a HOT 2000 or another simulation tool that's approved to design a custom way to meet the targets. So regional specifications, Ontario, we've touched on some of these topics here. Applying Energy Star for new homes to Ontario. So section 6.9, that's where we were for Ontario. We confirmed the correct climate zone for our site. We went out of zone 1. Climate zones are divided by heating degree days. We know that. It's exactly like SB 12 zones. Performance targets. Ontario has specific ESNH energy targets for modeling. These targets are tuned to exceed the provincial code for reference by about 20%. Remember, for that American video, they said it's exceeding by about 30%. Our energy targets are higher than theirs, so ours is aiming to go about 20% higher. And then electrical savings options. Electrical savings are specifically included measures for efficient air conditioning systems reflecting summer cooling loads. Ontario, as we've spoke on, is a very unique climate in the sense that we have extremely cold winters at times and extremely hot, humid summers at times. So when you're building Ontario, you're building in arguably one of the most difficult places on the planet just because of our very difficult temperature swings, but it just makes it all the more important to understand these topics. So air tightness requirements, this is the standard it's based off of. You do it off the table in the appendix. Free drywall, this is a topic that keeps coming up. I keep putting it in here because it's so important. Schedule your air barrier walkthrough before boarding. Mark all penetrations for sealing. Make sure you're detailing properly. Gaskets, specialized tapes, proper connections at rim joists, top plates, windows. Pre-test, if relying on tightness credits, perform a preliminary test and allow remediation time. So do the test before your building's done. Get someone in there and make sure you're meeting before you do your drywall so you have time to correct them before final verification testing. Doing air tightness improvements after finishes is a situation you do not want to find yourself in as a builder. It gets very difficult and it gets messy and it means tearing stuff out a lot of the time. So we're always doing that stuff before the final touches are on the building. So how to use Energy Star in general. Enroll in the project. Builder works with Enercan licensed service organization. Assign energy advisor early in design phase. So you meet with your energy advisor who's going to be managing your building. You choose your path. We've talked about the 2 paths. Are we going with a prescriptive builder option package or a performance-based model? Lock in the minimums, all these different specifications. We find out exactly where we need to be. We document all of our exact appliance models, electrical appliances. That's all the way down to light bulbs, We lock in our smart thermostats. We pick all these things that are going into our house beforehand, so we know where we're going to land. And we don't want to be waiting for products during the building construction phase. And then we verify and test. This is what's gets you your Energy Star credential at the end of the project, is the inspections, commissioning, the blower door test like we watched the video on, submitting your final data to the Energy Advisor for certification. So here's some practical examples. Zone 1, detached, prescriptive path, gas furnace, standard envelope, achieve 400 kilowatt savings via LED lighting package and Energy Star fridge and dishwasher or washer. I can't remember which one I went with there. Doesn't matter. We're not going to go deep into the 400 kilowatt, but I just wanted to show that you meet them through appliances. Zone 2, bungalow. So this is a bungalow. In zone 2 system, we're going with electric heat in this scenario. The path, performance modeling, walls plus continuous insulation of RSI 4.0, Windows U.14. These are just different examples of your strategy planning on how you're going to meet Energy Star for new homes. And then row townhouse. So this is your MURBs, your multi-unit residential buildings. Combination system for your HVAC, path, prescriptive, and tightness rating. So there, you can go with a prescriptive path, like using a builder option package, and then adding in a higher level of air tightness to get there for your points. And then some of the specs that are important in these multi-unit residential buildings are party walls, which are shared walls between 2 units, and detailing those to meet energy or air tightness per unit on its own. So for the rest of the class today, what I'm going to have you do is create a example. It can just be on paper of a compliance path. So I'm going to make a drop area in the assignments section. This is for completion. I just want to have you exercise doing a compliance path with the option points for anywhere you choose and any zone. So pick a province or territory, pick a zone you're working in, choose your compliance path or your compliance package, your builder option package, and then go to the options page, which is the next page over in the Energy Star for new homes document, and then just write down how many points you need, how many or where you're going to get them. So if you're getting them from upping the R value in your wall, if you're getting 0.5 points from that, then put down R value wall, put down the specific R value or RSI, whichever you choose, and beside it, put how many points you're getting from that. And then go and do the total for all of them, and then submit Newfoundland and Labrador, zone 3, I need 2.9 builder points or option points. Go down, select where you're getting your option points, and then just take a picture of your page and submit it online under the assignments. It's just for completion. If there's any questions on today's presentation, then please reach out via email and we'll get those cleared up. It'll be a good exercise just to use the document and try to make some builder option packages worked. You can do it for a couple. It really doesn't take long, but you can use the rest of the class time today to go through and make one and then submit it to me, and I'll be able to see if there's places we need improvement that we can go over. Thanks for tuning in. I appreciate it. Look forward to seeing you guys when I get back, and I'll follow up about Wednesday's lecture next. Have a good day, everyone.